Hello and welcome to today's geography lesson. Today we're going to discuss the last section on climatology, and that's local climate. In the previous lessons we look at mid-latitude cyclones and tropical cyclones. We will revise on this a bit later, but let's quickly finish the climate section by looking at local climate. Now, as the name indicates, it's local climate. It's climate that we experience in rural areas and urban areas. The two topics that we're going to discuss is valley climates and urban climates. Now, if we quickly look at, we're just going to start today's lesson with valley climates. And our first topic for today is going to be anabatic winds. Now, grade 12, please pay special attention to the name and to when it takes place. Anabatic winds happens during the daytime. As you can see in your diagram, you can see the sun shining. Now, very importantly, what do we know? If the sun is shining, we experience warm conditions. A different name for anabatic winds is upslope winds. As you can see, the surface, the valley floor that you see over there, warms up during the day. And by now, warm conditions, the air is less dense, and what does the air do? It rises upslope. Now, if you quickly look at a couple of characteristics, it's upslope valley winds, as you can see over there in the diagram. If you look at the second point, the slopes are being warmed during the day. Why is it being warm during the day? Because you have your sun over there. And thirdly, what's quite important, how does this air warm up? What makes it rise? Now, this is through the process of conduction. Conduction, you've learned in grade 10, is the heating of the atmosphere. Now, basically, the surface of the earth warms up. And as the air moves over it, what happens? It warms up the air. And because the air is being warmed up, what happens to the air? It starts to rise. Now, if you quickly look at our second slides with more characteristics over here, the air rises parallel to the slope. Upslope winds, we also call them upslope winds. Now, very importantly, if you go back to the diagram, you can see the air is moving parallel with the slopes. And what do we experience right here in the middle? Divergence. Now, with divergence of air taking place in opposite directions, what's being created in the middle? We're experiencing a downdraft. As you can see over here, because divergence is taking place over here, so we experience a downdraft in the middle of this valley. And as you can see, two distinct cells develop. Now, if you look at the diagram, very importantly, grade 12s, anabatic winds during the day. Why? Because slopes warms up, the air rises, it's less dense. We experience divergence in the middle, a downdraft is being created, and we've got two distinct cells that form inside our valley. Now, if we quickly look further at our characteristics of anabatic winds, the air rises parallel up the slope, like on the previous diagram. Let's quickly draw our slope in here. Let's say, for instance, this is our slope. Now, divergence takes place. That's where the divergence takes place, right over there. And obviously, a draft is being created in the middle because of the divergence. And there you can see two distinct cells has formed. Now, what's the effects of anabatic winds on a settlement? Now, keep in mind, when we refer to a settlement, it's where people live. Now, many people do live in valley areas, and obviously it have a direct implication on the settlement itself. In this case, we've jumped a couple over there, just want to go back. In this case, it actually helps with pollution. Because what it does is, with the rising air, that rises upslope. Now, if you look at pollution, if you think of pollution, pollution is usually smoke, CO2 gases, and if you look at it, it's usually, what does it do? With the adiabatic winds, it carries this pollution out of the valley area. It's quite vitally important, and it creates a healthier living space for the settlement. Now, our second valley winds that we're going to look at is the opposite from adiabatic winds, and those are known as katabatic winds. Very important, grade 12s. Katabatic winds happen during night. Now, if you look at our diagram over here, as you can see, the moon has been cut in half over there. What happens during night time? What happens with temperature when it cools? It sinks. So in this case, if you look at the katabatic breezes, it's downslope winds, because the air moves downslope in the valley floor. Now, the reason for this, temperature cools by the mean of conduction. We looked at it, what happens? Air temperature cools, the land cools. Conduction is the mean of touch. This air moves over the cold land and it collects on the bottom of the valley. Now, if you look at some of the characteristics, like I've mentioned, is downslope winds. The reason why because cold air sinks to the bottom of it through the means of conduction. Now, obviously by now you should know, we've learned it in the previous section. If you look at cold air, it's less dense, so we can actually say it's heavier. So it's sinking down to the bottom of the valley. Now, the air sinks parallel with the slope. I don't want to jump back to my previous slide, so I'm just going to draw it over here. Now, it comes into contact with the slope. What happens? It cools via the means of conduction by touch. Right, call it downslope winds, as you can see over there. And very importantly, if you look at this term over here, convergence, we've learned it in the previous section, is the coming together of two air masses. So what happens in the middle? An updraft is being created. Why? Because it's not like this cold air that collects on the bottom of the valley can go through the valley. What happens? And pushed upwards. And once again, two distinct cells have developed. Now, during winter, we experience a valley inversion, usually during the winter months. And this valley inversion has quite a massive impact on settlements around us. It's the way we farm, it's the way we live. That's how big this valley inversion plays on settlement during winter months. Now, we experience a valley inversion, a nocturnal valley inversion, usually during the winter. Now, by now, if you look at your two previous diagrams, very importantly, it experienced during katabatic winds. Why? Because during at night time is when the temperature cools down. Now, what experience, because of extreme cold temperatures, what happens to the cold air? It sinks to the bottom of the valley. Now, keep in mind, because of terrestrial radiation, what happens? This cold air sinks from the surrounding area to the bottom of the valley. The air that was inside the valley is warm air. Now, what do we know? What's happening if cold air sinks down the valley? What's it going to do with the warm air? It's going to displace it. What's going to happen with this warm air? It's going to force it to rise. So what happens with this warm air? All this warm air has been uplifted. Now, the reason why this warm air is being uplifted, because what happens down here? Convergence. As you can see, the cold air, if you look over here at the valley, at night time the cold katabatic winds subside. It means it's sinking. The warm air in the bottom of the valley is being forced to rise. And then the thermal belt is being created. And this area over here is the thermal belt. Now this thermal belt creates the inversion layer. Now the first time you were introduced to inversion layers was in grade 10 when we look at the structure of the atmosphere. Now an inversion layer is basically an abnormal lapse rate. Now we discussed it in the previous lessons. If I'm standing over here and I go and climb Kilimanjaro, what's happening with the temperature? The temperature is decreasing with altitude. But what happens with the inversion? It's an increase of temperature with an increase of altitude. For example, all the cold air collected on the bottom of the valley. Where this cold air collects is known as the frost pocket. So all the cold air collects on the bottom of the valley, creating an area known as the frost pocket. What happened to the warm air? The warm air is being forced to rise because of the cold air coming from the sides, creating this thermal belt. So if I had to write temperatures in here, in the bottom of the valley, we're going to experience -1 degree Celsius. It's referred to as the frost pocket. What is frost? When the dew point temperature is below 0 degrees Celsius, when water vapor turns directly into ice. Then, where the inversion layer is, the thermal belt, this area over here, we experience warmer temperatures of 4 degrees Celsius. Do you see the inversion? Now we're moving up with altitude. In theory, what needs to happen? The temperature needs to decrease with altitude. But in this case, the temperature is increasing. Why? Because of the cold surrounding air sinking to the bottom of the valley, creating the frost pocket, forcing all the warm air to rise, creating the thermal belt. Now, once again, if we move out of the valley, we will experience a positive lapse rate because we go from warm to cold with altitude. So it means no inversion is taking place over there. Now, this is quite important, the way settlements are taking place. But just quickly look at those characteristics that we written down there. Now, obviously, the katabatic winds, because of cold temperatures, what happens? It sinks down to the bottom of the valley floor. As you can see, there's another diagram. If we can just quickly start drawing over here, the cold air sinking to the bottom of the valley. What do we call what happens over here? Convergence taking place. What happens to the warm air? It's being displaced into this area over here, known as the thermal belt. And as you can see, this is where our inversion is taking place. It's cold over there, and it's warm over there. Now, these valley inversions can be a problem for urban settlements and also for rural areas where farming is taking place. Why? Because first of all, we're experiencing a frost pocket. There's extremely cold conditions. And as you can see, if we do experience urban settlements, the pollution are being trapped below the inversion layer. Now, as you can see, because of this katabatic winds, because of the inversion layer over there, all the pollution are getting trapped below the inversion layer, creating smog. Now, what is smog? It's a mixture of fog and pollution. Now, these also have effects on farming. For instance, if a farmer do farm in an area that's situated in a valley, he needs to be able to plant frost-resistant type of crops. Frost-resistant type of crops is crops that can withstand the frost. It means it won't actually kill the crops that's being farmed over there. And for settlement purposes, instead of living on the bottom of the valley, we rather go and live in the thermal belt area because we're experiencing warmer conditions. Now, many settlements are already overpopulated. And our next topic we'll have a look, we tend to settle on north-facing slopes because they receive direct insolation. But now in valley areas where it's overpopulated, people can go and settle on the south-facing slopes as well, inside the thermal belt because there's warmer conditions. Now from a farming point of view, like I've mentioned, you need to farm your crops that's frost resistant down there, and you can farm the rest of your crops that can't withstand any frost halfway up the slopes where warmer conditions are being experienced. Now let's just quickly recap. If we look at our katabatic breeze, as you can see, katabatic breezes happens during the night time. It's sinking air. Okay, when we look at these katabatic breezes, there's convergence taking place down in the bottom over there. Now what's being created? An updraft is being created and two distinct cells is being formed. Okay, after the break we quickly recap on valley inversions. See you then.